Very good morning and greetings, friends. Today we are going to see the solid mechanics course in the topic of trusses. All of you know that the trusses are used in the case of the industrial buildings and also the case of the sheds like car sheds or the cycle sheds or the two-wheeler parking. So in that we can see that the trusses are used with the help of the column as a support member or the wall as a support member, and it consists of the number of vertical, horizontal and also the inclined members. These members may be of compression or tension. So if you are taking the 2D trusses, you can able to find the forces in all the members, whether it is a horizontal, vertical or the inclined members or the top chord and the bottom chord members, by the application of the method of joints or graphical method or method of sections, or in the case of 3D you can use the tension coefficient method. But we are going to see now only the 2D type of stresses. The simple form of the truss is a triangle. So it consists of one horizontal and two inclined members. The bottom member, which is called as a bottom chord member, so mainly it is subjected to the tensile force, and the inclined members will be subject to normally a compressive members, or the vertical member in the case of any other type of trusses will be of mostly of a compression or a tensile member. So in the case of trusses, the load should be applied only at the joint point. Joint is nothing but the meeting of two members, which is called as a joint. So joint can be taken by means of the notation J. The member can be denoted by the notation M. For these type of stresses, whether it is a determinate stresses or the indeterminate stresses, you have to use the equation M is equal to 2J minus 3, where M is the number of members and J is the number of joints. If M is not equal to 2J minus 3, it is called as either deficient member or the redundant members. So the trusses may be of deficient trusses or the redundant trusses. If you want to make the deficient or redundant trusses into a perfect truss, we have to add or delete some members so that it become the deficit to the perfect members. So here, if you are taking the trusses, generally you are in the case of a triangle, simple triangle, it will be supported by means of the column or the wall. So that is, you have to find the reactions, the number of constraints. So one type of stuff is a hinge support and the other is a roller, for example. So there are three reactions: vertical, horizontal at one hinge joint, and the roller support we have one constraint or the vertical reactions. And the number of member here is 3, that is M is equal to 3. The number of joint is 3 also. So M is equal to 2J minus 3. If you are substituting it, 3 is equal to 2 into J, 2 into 3 minus 3. So 6 minus 3, that is equal to 3. So the left hand side is 3 and right hand side of the equation 2J minus 3 is 3. So here So 3 is equal to 3 is satisfying the perfect stress. Suppose if you are taking the member which is more than 3, some additional member you are putting it, the joint may be the same. So the number of member is, for example, 5, and joint is 3, means 2 into j, 2 into 3, or if you are putting 5 members, 2 into 5, 10 minus 3, you will get around 7. So left hand side is 3, right hand side is 7. So m is not equal to 2j minus 3. So here the number of member is more. That means you have to get some member to make it as a perfect stress. How many members you have to take the redundant value? 4 members you have to reduce it. So that we have to see that the truss is a stable and perfect stress. Suppose you are not, if you are removing some important member in a truss, it may not be stable. So we have to see that the number of members should be reduced in such a way that the stability of the trusses should not be disturbed. So each and every joint, for example, here there are 3 joints, A, B, and C, and the load is applied at the top, that is joint B. So you have to take each and every joint A, B, and C. So first I am taking the joint A. So in that case, you apply for the equilibrium. M is equal to 2j minus 3. You know the reaction, other 2 members. One is a horizontal, another is a inclined member. So from this equation, you can solve the 2 unknowns, the member horizontal and the inclined member. So similarly, you have to go for joint by joint. Next, you take joint by joint. So only two unknown members should be there. So you can easily solve it. Similarly, you can take any number of joints you can analyze by using method of joints. So it is a very easy method. So you should be careful in solving this. M is equal to j minus 3. After determining it, you can check whether your member forces are equal is correct or not. So if you are substituting at any joint, right, finally you will get m is equal to 2j minus 3. Or if you are applying the vertical equilibrium, sigma v equal to 0 or sigma fy is equal to 0. So if you are taking all the vertical forces should be equal to 0. Similarly, if you are taking all the horizontal forces, again it should be equal to 0. Then only the will be a check value for the determined value of the given force members. So all the forces will be of tensile force or compressive force. It may be of tensile member or compressive member. So this is about the method of joints. So in the next video we can see the method of section and some of the examples which is adapted in the method of sections. So in the method of sections, if you are taking the number of unknowns should be very less, and we can take the section at any value of the trusses, so that the number of unknowns should be of maximum of 2, so that you can easily find the member. So the method of section can be used where only 2 or 3 member forces can be determined, but you can have a number of members is 15 or 20, number of joints is similarly you have 10 or 15. So in that case, for a few members, right, 2 or 3 members, you cannot solve by means of method of joints, right? It will take a lot of time. So in the case of method of section, you can easily solve it so that you can reduce the time. So if time is concerned, you can go for the method of sections, or the 2 or 3 member forces required, you can go for the method of sections. Thank you very much for patient listening. God bless. வாழ்க வையகம், வாழ்க வளமுடன்.